when I looked at it is the you said microsphere, so the size and the let's say the actuation mechanism. I mean the locomotion mechanism. What's the hypothesis?
Yeah. One parameter that plays a role is pressure as an agent moves throughout the atmosphere. And another parameter is that maybe we should introduce, we will look further into that, but maybe we could introduce like a small pump that could regulate could inflate or deflate.
Definitely, I think more direct about these things. Like, so for example, because you're talking about a lot of details, I know you guys are tired, but because you have the scale of the aerosol, you know, we're talking about it as literal atmosphere, right? And then you have some of the balloon experiments that are giving an example of, you know, physical experiments, but you show some of the ones, let's say, that are in the world, like the dropping experiments and all of those things. So the issue of scale is something that is abstract, because in some sense, it's not like you're making lots of mechanical elements that are going to be populating. On the other hand, it has to be something that's almost like a smart dust strategy, right? That it is part of the atmosphere, that it's moving within these wind streams. So I think those kind of things, it's not a trick question from Patrick's statement.
No, I was just wondering if you want to direct it, then it might have to it can't be fully passive. I don't know.
I think it's true, yeah. Patrick. And these are where the conversations are about how much are these things, you know, somehow active and how much of it is passive. They try to opportunize passive strategies, but those are, you know, at some sense limited. But what they're trying to do is really to try to trigger atmospheres in moments of need, you know, to kind of instantiate the water, the vaporization and all of these things. I think the project is, I mean, from my perspective, quite fascinating. And I like the fact that there has been an attempt to really try to use almost like science experiment strategy to start to gain an insight about how we can control things. So, for example, like prior to all of these experiments, especially the ones that you did with the dry ice, idea of temperature or the sensitivity to that was a kind of abstract concept, right? Even if we knew the temperatures, we didn't see the effect. So I think some of those experiments with the heated water, where you start to see the control variables as a kind of active attempt to be able to start to understand that and to gain an intuition, I think those were very positive. And you could see those kind of pattern strategies in some of the particle simulations that you guys were dealing with. So you start to kind of collaborate a kind of strategy to think about how these agents, in some sense, the way that they're triggering these kind of water vapor molecules and the aerosols and so forth is really about those temperature differentiations, and how they create microclimates within a stream is also something that can be amazingly localized. So I think that there is good attempts to start to bridge those gaps so that the project gets more tangible. The issue of control that Patrick is kind of bringing up to the conversation, I think, is important, because unlike some of the previous kind of, let's say, flying projects, which was more about explicit control, this one lends itself to explicit control in terms of temperature regulation, right? But not explicit control in terms of movement behavior. So I think even the way that we start to try to take the next steps of how one starts to simulate this, I think it's very important to start to try to gain insight in that. And what is the local relationships that we're trying to address? Like right now, we're primarily focused on that transition from extracting from the air water. Now, the question about how that becomes a vessel or a carrier, how it's interfaced to the ground, these are other aspects of the project as well. So I think that there's an intuition from the app, but I think I've mentioned this before. The app, I think, is a good tool, but in most of the scenarios of super survival situations, these things are not necessarily so technological. So I think the attention to how we somehow develop the machine learning strategies for the people that are on the receiving end of things, or from the people that are somehow working to, let's say, bring the resources to people, I think that is going to be some part of the development that we'll have to take a position on at some moment in time. Because I think, like in some of your examples, those kind of rain catchers, this kind of very primitive architecture, those are in places that are not really technological. That's not going to be an app for people. But that doesn't mean that that's not part of a larger kind of coordinated network of things. So when you see this as a piece of infrastructure, it opens itself up to a different idea of how things are communicated and what's regulated and how those things are instantiated. So I think that there's been good progress on that, and I like that the machine learning elements are starting to come into the conversation, because it has to have internal self-regulatory strategies, right? It's not like a thermostat that's responding just to an environment. It should be triggering, like the thermostat being connected to the heater and something, a kind of self-regulation in terms of triggering those kind of elements. So I don't think it's so far-fetched to think about what the climatic control strategy for this could be. But I think that there are, beginning steps of actually how this is working.
I wonder if I'm getting it right. So you could have potentially, if you have some energy harvesting, you could heat up the air, and that would push the particle up. And then you also talk about inflation, which also would inflate, and heat would move you up into the atmosphere and then stop heating, maybe even cooling, and deflation would drop this thing. But then you leave all lateral movement to passively. I just wonder where that leaves. I mean, you have to. I wonder if that enough to contain to target the cloud.
I think that those are questions, Patrick, that they need to take the next steps in simulation. They try just moving vectorially up and down in the first kind of attempts, and I think that there was a lot gained. Now, the issue about how much energy it takes to stabilize that.
You might have some solar cells on the thing.
Yeah, I mean, some of these foils and stuff, like in those parachutes, like in 108 and so forth, I mean, they're the similar kind of materials that are used for people when they're dealing with hypothermia and stuff like that, and they want to change the body heat quite drastically. Some of these materials, if they're used in an intelligent way, I think could do a lot. So I think like the aspects of taking on some of that material challenges in terms of how energy and temperature is being self-regulated in the actual element itself, I think is something that we could start to experiment a little bit further from the balloon experiments that you guys did. And just in terms of understanding the behaviors of these things and to limit the mechanical strategies, I think Patrick's active-passive discussion, I think, is an important one, where we have to use now some of those simulation strategies, like where you say a chunk of air, and really try to test how those things can respond to different forces, so that we get some kind of metrics in terms of energy and heat and temperature, and that variability. I don't think we need to play quasi-science about that in a mechanical sense, I think we just need to start to understand the behaviors a little bit more. Like some of these simulations already are showing the similar features that you saw in the dry ice experiment. So that's where I think the dry ice experiments are interesting, because if it's on the ground, it behaves in a certain way. If it's dropping, it behaves in a different way. The things that we're trying is to create the kind of tipping point or the triggering point to extract the moisture outside of this volume of air, right? So this is the way that you have to keep pushing that. But I think you're showing some good inventiveness in bringing these things together. So you just have to keep going, and we'll introduce more more understanding as we start to bridge those gaps a little bit further. I think the material experiments have further things to do, because we don't have velocities. You just have fixed points when the dry ice is just kind of dropping, and we know that there's dissipation rates as soon as there's any movement. I mean, when we did Memory Cloud, it was very clear. Accelerated movement, basically accelerates dissipation in a sense.
Yeah, I find it very fascinating, and actually I congratulate you for the amount of digital experimentation. I quite like the dry ice work as well. It has potential. It shows, for instance, the idea of corrugation as a way of, let's say, holding some of this moisture, some of these kind of denser conditions. Versus the idea of glossy kind of smooth shapes that somehow like have the capability to kind of create less friction. In that sense, that also like the idea of the different layers of the stratosphere, I think that's quite interesting. And I would say, looking at the idea of harvesting energy, maybe you can take advantage of those different directions, those different kind of intensities of the wind, or even like influenced by the gravitational field. Those kind of movements and potential energies are can be quite useful at different altitudes, no? So you can also like play almost like as a sort of like you can inflate, deflate the elements and try to reach different levels to harvest in the best way, almost like a sort of jiu-jitsu, trying to, let's say, kind of capture the energy of the opposite fighter, like you, or even like in, using gravitational fields to accelerate for space shuttles or spaceships, like those kind of tricks I think are quite useful. And since you are looking at something that is very subtle and very kind of gentle in the way it interacts, so I think, one way also to deal with this issue is that you are not going to kind of go totally in contrast with the flow, but somehow like you can take advantage of the flow to deliver certain postures and figures with your clouds, I guess.
You're becoming very Bruce Lee, my friend. Sajay, any finishing comments?
No, I think like a lot of has been said, like, and I think like we see for the next 2 weeks or the next review. I mean, I agree with like it is a fascinating idea to be able to geoengineer climate, but I suspect like we'll discover that like there's more design interest in like local clusters of manipulating rather than like the kind of global planetary scale systems, which I think like are a bit less believable, and also maybe in the long run design wise it's less interesting. I think like it's microclimates, the idea of like structuring microclimates in relation to in relation to the built environment, like that, I think is quite an interesting topic to address, with like all these studies, which are kind of operating in a petri dish type of scenario. Like, but now we need to try and situate them in some kind of context, right? Like, and give it a more targeted goal. Like, but for now, I think like the first 3 weeks of this workshop have been very productive. So I'll reserve my comments for the next time.
It's good. Sajay suspending disbelief for 2 weeks, so you guys have some work to do. Okay, guys. Thanks for that. We'll move on.
Thank you very much.
Can you guys unshare your screen? Okay, so then we go Patrick or Sajay, Patrick, and